Far out in the cold, dark expanse of our solar system, orbiting the gas giant Jupiter, is a world that might hold one of humanity's greatest discoveries. This is Europa, a moon covered not in rock and dust, but in a thick, global shell of water ice. At first glance, it appears as a serene, marbled sphere, crisscrossed with dark, reddish-brown fractures. But beneath this frozen surface, something extraordinary is believed to exist, a vast, liquid water ocean. This isn't just a small, trapped reservoir of water. Scientists theorize that Europa's ocean could be more than 60 miles deep, containing over twice the amount of water found in all of Earth's oceans combined. How can a world so far from the sun, where surface temperatures plummet to -260 degrees Fahrenheit, possibly harbor liquid water? The answer lies with its colossal planetary neighbor, Jupiter. Jupiter's immense gravitational pull constantly tugs and stretches Europa. This gravitational flexing generates friction and heat deep within the moon's core, a process known as tidal heating. This internal furnace is powerful enough to keep the subterranean ocean from freezing solid, creating a stable, potentially habitable environment that has likely existed for billions of years. The icy shell acts as a protective blanket, shielding the ocean below from the intense radiation that bombards Jupiter's system. But what makes this hidden ocean so compelling is not just the presence of water. Scientists believe it may contain all the key ingredients necessary for life as we know it. The first ingredient is, of course, liquid water. It's the universal solvent, facilitating the chemical reactions that are the very foundation of biology on Earth. Europa has this in abundance. The second ingredient is a source of energy. While sunlight can't reach the depths of Europa's ocean, the tidal heating that keeps the water liquid could also power hydrothermal vents on the ocean floor. On Earth, these deep-sea vents are oases of life, teeming with complex ecosystems that thrive in complete darkness. They spew out a cocktail of superheated, mineral-rich water, providing both the chemical building blocks and the energy that organisms need to survive. If similar vents exist on Europa's seafloor, they could be the engines of a completely alien biosphere, one that has never seen the light of the sun. The third essential ingredient is the right mix of chemical elements. We need elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur to build the complex molecules of life. Evidence suggests that Europa's ocean is not pure water. The reddish-brown streaks and chaotic terrain on its surface are thought to be salts and other compounds that have welled up from the ocean below and been altered by radiation. This indicates a rich chemical interaction between the water and the rocky seafloor. The ocean is likely salty, much like Earth's, and could be rich in the very elements needed to construct everything from simple amino acids to complex organic structures. So, we have a protected, long-lived ocean with water, a potential energy source, and the necessary chemical building blocks. This raises the ultimate question: has life actually emerged in this dark, subterranean world? And if it has, what might it look like? When scientists speculate about life on Europa, they often draw parallels to Earth's own deep oceans. Perhaps we could find simple, single-celled organisms, similar to the bacteria and archaea that cluster around our planet's hydrothermal vents. These microbes could form the base of a food chain, metabolizing chemicals like hydrogen sulfide to create energy, a process known as chemosynthesis. But the conditions on Europa may have allowed for something more. The sheer scale and stability of Europa's ocean, existing for billions of years, provides an immense amount of time for evolution to work its magic. Could life have evolved beyond the microbial stage? Some scientists have dared to imagine more complex organisms. In the total darkness of this alien sea, life wouldn't rely on sight as we know it. Instead, creatures might navigate using sonar, bioluminescence, or highly sensitive pressure and chemical sensors. The high-pressure environment of a deep ocean would favor bodies that are resilient and flexible. This has led to some exciting, albeit speculative, ideas about what complex European life might look like. Think of creatures analogous to Earth's deep sea life, gelatinous beings, bizarre fish-like swimmers, or perhaps even large, intelligent predators. Some have even floated the idea of something akin to a giant squid or octopus, a highly intelligent and adaptable creature perfectly suited for a dark, three-dimensional aquatic world. While the idea of giant squids on Europa captures the imagination, it's important to remember that this is pure speculation. For now, the primary search is for any sign of life, no matter how small. Even finding the chemical signature of a single microbe would be a profound, world-changing discovery. It would tell us that life is not a unique miracle of Earth, but a common cosmic occurrence that can arise wherever the conditions are right. and we are on the verge of finally being able to look. Humanity is not content to simply wonder from afar. We are actively preparing to send our robotic emissaries to investigate Europa up close. NASA's Europa Clipper mission is set to launch and will perform dozens of close flybys of the Moon. Equipped with a suite of powerful scientific instruments, Clipper will not be looking for life directly. Its main objective is to confirm the presence and characteristics of the ocean, measure the thickness of the ice shell, and scan for potential landing sites for future missions. Its ice-penetrating radar will map the boundary between the ice and the ocean below. Spectrometers will analyze the composition of the surface, looking for organic molecules and salts that have been brought up from the depths. A magnetometer will measure the Moon's magnetic field, which can give us clues about the ocean's depth and salinity. Clipper will essentially conduct a reconnaissance of Europa, painting the most detailed picture we've ever had of this potential cradle of life. Following Clipper, the European Space Agency is sending its own mission, the Jupiter Icy Moons Explorer, or JUICE. While JUICE will study multiple Jovian moons, it will also perform crucial flybys of Europa, complementing Clipper's data and giving us a more complete understanding. But the ultimate goal is to go one step further. The dream is to land a probe on the surface of Europa. A future lander mission could drill or melt its way through the ice shell. Imagine a submersible, a robotic explorer descending through miles of ice before breaking through into the liquid ocean below. It would switch on its lights, illuminating a world that has been dark for billions of years. What would it find in that black, silent abyss? The possibilities are staggering. This is no longer the realm of science fiction. These are missions that are being built and planned right now. The journey to Europa represents a pivotal moment in our quest to understand our place in the universe. It is a search for a second Genesis, for life beyond our own planet. The answers we find at Europa, whether we discover a thriving ecosystem or a sterile ocean, will reshape our understanding of biology and the potential for life elsewhere in the cosmos. The ocean beneath the ice is waiting. The journey is just beginning, and we are incredibly fortunate to live in a time when we can dare to ask these questions and build the machines to find the answers. Thank you for joining us on this exploration of Europa's hidden ocean. If you found this journey as fascinating as we did, be sure to subscribe to Space Repo for more deep dives into the mysteries of our cosmos.